Welcome to my lecture. Today we are going to carry out engine force analysis. Okay, so in which we are going to calculate piston effort, force, or we can say that is a thrust along the connecting rod, thrust on the sides of cylinder walls, crank effort, thrust on crankshaft bearing, and finally we are going to find out the turning moment on the crankshaft. Okay, so in engine force analysis, so these are all the forces which are going to be acting on the engine. So for that we have to find out these forces. Okay, first we will see what are all the forces that are acting on an engine. Okay, the first one is weight of the reciprocating masses and connecting rod. Okay, so that we know that. Okay, so the piston is the reciprocating mass. Okay, it is the reciprocating mass. Okay, so it has certain mass. Okay, similarly the connecting rod which is oscillating also having certain mass. Okay, so the connecting rod and the piston which is reciprocating has certain masses. Due to that they have certain weight. Okay, so weight is acting in the engine. Okay, so weight of the reciprocating masses and connecting rod. And the second thing is it is the driving force. Okay, gas force. So during power stroke we have a gas forces. Okay, so during the power stroke of the engine we get power, okay, which pushes this piston towards this direction so that we can get turning moment at the crankshaft. Okay, fine. So the gas force is the external force which is applied during the power stroke. Okay, and the third one is friction and inertia forces due to acceleration and retardation of an engine elements. Okay, the friction force comes into picture whenever two bodies are in contact. Okay, so here piston is moving this direction, so if the movement is this direction, the frictional force opposes the motion. Okay, the frictional force will be in the opposite direction. Similarly, the inertia forces acting opposite to that of the motion. Okay, so friction and inertia forces also coming into picture. Okay, as far as engine force analysis is concerned. Okay, so first thing is weight of the reciprocating mass and connecting rod, gas forces which is externally applied to the system. Okay, and then friction and inertia forces which are caused due to the acceleration and retardation, that means the deacceleration of the engine elements. Okay, fine. So these are all the forces which are acting in the engine. Okay, the next thing I just want to say here is it is the cross section of the reciprocating engine. Okay, here it is the crankshaft. Okay, it is the crankshaft. Okay, this element. Okay, and this is the crank. Okay, this is the crank. Fine. Okay, this is the crank, and this one is connecting rod, and this one is the connecting rod. This one is the connecting rod, and here this end. Okay, the point at which the connecting rod joins with piston, the area that we say that as a small end. Okay, the bearing which lies inside this joint we call that a small end bearing. Okay, small end bearing. Similarly, the pin which is used to connect these two elements, that means piston and the connecting rod, we call that as gudgeon pin. Okay, gudgeon pin. So these are all the uh, components name that we need to remember. Okay, so this is a piston that everybody knows, and it is a cylinder. Okay, so the piston just move up and down within this cylinder. Okay, so here it is a vertical engine, so this is supposed to be top dead center, and this is supposed to be your bottom dead center. Okay, fine. So and it is a flywheel which is connected at the end of the crankshaft. Okay. Similarly, so here we have seen that it is a small end, the region which connects piston and the connecting rod. On the other hand, in this side, we have a big end. So the region where the connecting rod and the crank gets joint. Okay, so this end we call that as big end, and the bearing which is housed inside this region we call that as big end bearing. Okay, so these are all the name that we need to remember while solving the problem, and also a practical thing is concerned. Okay, this is the top dead center, this is the bottom dead center. Okay, this is a piston, it's a piston. Okay, so which reciprocate within this cylinder. Okay, so now we are going to see what is piston effort. Okay, so that means it is a net effective force applied on the piston. Okay, net effective force applied on the piston. So otherwise we can call that net load on the gudgeon pin. Net load on the gudgeon pin. So that means the resultant force. What is this? The resultant force. The resultant force which is acting on the piston is called piston effort. Okay, in other words we can say it is a net resultant force which is acting on the piston, that is piston effort. Okay, the resultant force is, we call that as piston effort. Okay, piston effort, so the short name is F suffix P. Okay, it is a net resultant force which is acting on the piston. Okay, fine. So how it behaves during first half of the stroke and during the later half of the stroke. Okay, so during the first half of the stroke, what happens is the reciprocating masses accelerate. Okay, so that means when it moves from top dead center to bottom dead center, up to this point, exactly at center, it accelerates. So from this point to this point, what happens is acceleration. Okay, fine. At this point to this point, what happens is retardation, or otherwise it is deceleration. Okay, from this point to this point. Okay, TDC to this center point, what happens? Acceleration happens. From this center point to PDC, what happens? Retardation, that is a deceleration. So it is the off of the stroke, it is the later half of the stroke, it is the first half of the stroke. Okay, okay, so during the first half of the stroke the reciprocating masses accelerate. Okay, so the inertia force resists the same, that means the piston effort is being resisted by the inertia force. Okay, because the inertia force acts in the opposite direction to that of the applied gas pressure, that means gas load. Okay, so during the first half of the stroke, what happens is, due to the acceleration of the masses, the inertia forces resist the motion of the entire system. Okay, so the net force on the piston is decreased. Okay, so the net force on the piston is decreased to some extent. Okay, because what happens is the inertia forces opposes the motion. Okay, fine. And then let's talk about what would happen during the later half of the stroke, and this is the later half of the stroke from this center point to PDC. Okay, so during that time, what happens is the reciprocating masses deaccelerate. That means it has to come to rest at this point. Then again, it has to move to the TDC. So this cycle continues. So during the retardation, what happens is the same inertia forces acting along the direction of the applied gas pressure. Okay, if gas load is acting in this direction, so the inertia force is also acting along the same direction of the applied force, so it helps the motion. Okay, it helps the motion. Okay, so at the end, the net force on the piston got increased, because what happened during the retardation, the gas load which is being applied on the piston is get just multiplied by means of action of the inertia force, because the inertia force, as long as it reaches this point, it is acting in the opposite direction. That means up to this point it is acting in this direction, that is inertia force. Okay, because acceleration, inertia force is going to oppose the that motion, so inertia force going to be opposing the motion, so up to this point. Okay, later part of these things, it is deacceleration, that is negative acceleration. So from this point onwards, what happens is the inertia force direction gets changed and it is going in the downwards direction. That means along the direction of the gas pressure. So it helps the motion. Okay, that is why here it is mentioned that net force on the piston got increased during the later half of the stroke. Fine. Okay, so this is a concept that you need to understand. So what would happen during the first half of the stroke? So what is going to happen during the later half of the stroke? Because here it accelerates from TDC to this center point, and this is the later half of the stroke. Okay, so the entire thing is called, we call that as one stroke. Okay, it is a part of that one and it is a second part. So it accelerates here, the piston here, it deaccelerates, that is retardation. So what would happen? The inertia force gets reversed. Okay, so the reversed inertia force help the motion. Okay, because it's going to be along the direction of the applied gas force, because it helps, because of that it helps the motion. Fine. Okay, so next we are going to uh, think about of a vertical engine. Okay, so what would exactly happen in a vertical engine? Okay, so for a horizontal engine, I told you earlier, the weight will not comes into picture. Okay, because as far as horizontal engine is concerned, the weight of the reciprocating masses does not lie along the line of motion. Okay, so in horizontal case, okay, piston is going to move like this. Okay, so piston, so the weight of the piston is going to be acting in the downwards direction. Okay, the weight of the reciprocating parts. Okay, but motion happens in this direction. So line of stroke is here, so it is the line of stroke. So there is no direct connection between this motion and the weight of the reciprocating mass. Okay. On the other hand, in vertical engine, the piston mass, that is the mass of the reciprocating parts, exactly acting, okay, in the same direction of the motion, because the motion happened this direction. It is the line of stroke. Okay, so it is exactly acting along the direction of the motion. So it influences the piston effort. Okay, it influences the piston effort. Okay, to a larger extent. So that is what the thing we are going to see. Okay, so here I'm just taking it as a two stroke. What is one? First thing is it is just moving from this point to this point. That is it is a top dead center and it is the bottom dead center. Okay, it just moves from here to there. Okay, it is the downstroke. It is the downstroke. So during the downstroke, what happens is the weight of the piston, okay, assists the motion, because it also acting in this direction. So the motion is also in this direction. So what happens is it increases the piston effort by an amount equal to the weight of the piston. Okay, so it increases the piston effort, okay, by an amount equal to the weight of the piston. Okay, so when it moves from TDC to PDC, that is downstroke, during the downstroke. Okay, so now let us see what would happen during the upstroke. Okay, so during the upstroke, what happens is uh, the piston just moves from this PDC to TDC. Okay, so what happens is, okay, so the motion is in the upward direction. On the other hand, weight is always going to be acting in the downwards direction. So it is due to the gravity. Okay, so it opposes the motion. Okay, because when the piston moves from PDC to TDC, it has to move in the upward direction. Okay, during the upstroke. So the direction of the motion and the direction at which the weight is acting are opposite in nature. So what happens is it resists the motion. Okay, so decreasing the piston effort by an amount equal to the weight of the piston. Okay, so we need to understand that in a vertical engine, so what happens is during the downstroke, the weight of the reciprocating parts help the motion. On the other hand, during the upstroke, it resists the motion. Okay, it decreases the piston effort by an amount equal to the weight of the piston. Okay, this is the thing that we need to know as far as piston effort in a vertical engine is concerned. Okay, fine. So next, we are going to derive the equation of piston effort. Okay, so I told you it is the exactly the resultant force. So resultant force acting on the piston, okay, along the direction of the motion. Okay, so piston is here. So what is the resultant force? Okay, it is the resultant force. Okay, it is the resultant force. So what is the resultant force which is acting on the piston? That is what piston effort is. Okay, how to find out that? Okay, so we have so many loads which are acting on the piston. Okay, so what are all those loads? Okay, piston is here. The first load is, okay, it is FL. Okay, it is the gas pressure. Okay, it is a load which is acting on the piston due to the gas pressure. Okay, fine. So if the motion is in this direction, what would happen? The inertia forces are in the opposite direction and the friction force is in the opposite direction. So what is the net force? So FP is FL minus Fi minus F. So this is the thing that is given here. Okay, this is the resultant force which is acting on the piston along the direction of the motion. Fine. So how to find out? So we need to know what is force on the piston due to gas pressure, and then what is inertia force and what is the frictional resistance. Okay, if you know these values, then we can find out the piston effort. Fine. So how to find out the inertia force? So here, so in the previous lectures we have seen how to derive the equation of this acceleration. Okay, acceleration of the piston. Fine. So inertia force is mass times the acceleration. So here I just put a suffix f, the r. The reason is it is the mass of the reciprocating parts. That means mass of the piston. Fine. So mass times the acceleration. So because substituted the value of acceleration here, instead of a I just replace this term. Okay, so mr, that is mass of the reciprocating parts, r omega square multiplied by cos theta plus cos 2 theta divided by n. So by applying this relation we can find out what is the inertia force which is acting on the piston. Fine. So now we are going to look at that this same equation for vertical engine. Okay, so vertical engine, I told you the weight of the piston also coming into picture. Okay, because it is along the direction of the motion. Okay, so the thing which we have seen is for horizontal engine, it is for horizontal engine. So here it is for a vertical engine. So the one thing which comes into picture here is the mass of the reciprocating parts and g, that is the weight of that piston. Okay, or reciprocating parts. Okay, these things is added with that previous equation. Because it is horizontal engine, it is vertical engine. Because as it is a vertical engine, the mass of the reciprocating parts plays a vital role during the motion. So it just considered here. Okay, so that is the weight of the piston is m or g. Okay, fine. So these things that we need to remember: what is the piston effort as far as horizontal engine is concerned, and what is the inertia force, and then the same piston effort for a vertical engine. Okay, so now we will discuss how to find out the force on the piston due to gas pressure. Okay, so during the power stroke I told you the gas pressure is going to be acting on the piston. That is the driving force as far as piston is concerned. So we need to convert that pressure into load, okay, in order to find out the piston effort. Okay, so this is the double acting cylinder. So here the pressure is going to be acting on both side of the piston, okay, both side of the piston. So here on this side it is P1, on this side it is going to be P2, okay. So P1, P2. Similarly, the area along this side, okay, so it is a cover end side, okay. This side we call that as, what is that, cover end side, okay. This side we call that as, okay, and this side we call that as a crank end side, okay. This side we call that as a crank end side, okay, fine. So this is P1, and the area, cross sectional area of this side is A1, and this side, that is the crank end side, the pressure is P2, and uh, the cross sectional area is A2, okay. So thing is, if you ignore the cross sectional area of the piston rod, so what would happen? A1 is going to be A2, okay. If area of piston rod is ignored, what is that? A1 is equal to A2, because if you are not provided with that dimension in the problem, we can just ignore that. We can take that as A1 is equal to A2, okay. On the other hand, if the dimension of the piston rod is given, okay, so the cross sectional area of the piston rod can be found, and then this load on the piston due to gas pressure can be found by using this equation. So we know that the force can be derived from the pressure and cross sectional area, okay. So this force is F is equal to PA, that is P1 A1 minus P2 A1 minus A. So this area, what we how we have calculated is, from this area, that is A1, from that we have subtracted this area of this piston rod. That is why we have put A1 minus A. Okay, so this is the procedure to calculate the load which is acting on the piston due to gas pressure. Okay, we must know, so what are the pressures which are acting on the cover end side and crank end side, okay, and what is the diameter of the cylinder, okay, and then piston rod dimensions also to be known, okay. If you know the dimension of the piston rod, we can find out this area, this A2, okay. So A2 is equal to, so here we have replaced it with A1 minus A. The reason is, it is the cross sectional area, that is A1 minus cross sectional area of this piston rod, that is what, A2. So that is the cross sectional area on the crank end side, fine. So this is the procedure if you need to apply to find the force on the piston due to gas pressure, okay, fine. So next what we are going to do is, we are going to find out the force along the connecting rod. So this is the force which is acting on the connecting rod, okay, that is F cube, okay. So how to find out this force? Uh, we are just going to take this element, what is it, piston. So we are going to construct the free body diagram of the piston. So here, this is the piston effort, okay. It is a net resultant force which is acting on the piston, okay. So we know how to calculate this value, okay. Fp is equal to Fl minus Fi minus F, frictional resistance. So in case of vertical engine, we have to add the mass times the acceleration due to gravity, that is the weight of the reciprocating parts also need to be considered to find out the Fp value, okay. So this is a net resultant force acting on the piston, and this is the force Fq, it is the force along the connecting rod, and this is the normal reaction, because the piston is just reciprocating over the cylinder walls, okay. So when you remove the cylinder, so here I need to add a reaction, that is Fn, okay. So these three forces are acting on this piston. So now let us see how to draw the force polygon, okay. So this is the first force, okay, there is Fp, okay. it is in the horizontal direction, and the next force is Fn. It is a reaction force due to that connection between cylinder wall and the piston. Okay, because I'm just removing the support, so what I have to do is I need to give suitable reaction. Okay, so this force, so I have just drawn a line just exactly in the vertical direction. Okay, fine. So the third one is Fq. This is what that force which is acting along the connecting rod. Okay, and this angle is phi. Okay, this angle is phi. So this angle. Okay, it is this angle. So now I want to know what is the force Fq. What is the force Fq? So how to find out that force? Okay, so let us take cos phi, which is equal to adjacent side divided by this hypotenuse. Okay, cos pi is equal to Fp divided by Fq. So I need this force, that is force along the connecting rod, Fq. So Fq is Fp divided by cos pi. Okay, so it can easily be found from that. So this is the formula that we need to remember to find the force along the connecting rod, Fq value. Okay, so now I'm also interested in finding this force, that is the reaction force. The name of that force is thrust on the sides of cylinder walls. Okay, what is the amount of force which which are acting on the cylinder walls? Okay, that is this force. Okay, what is that? Fn. So this reaction force. Okay, that is the thrust which is acting on the cylinder wall. How to find out? So the same trigonometry condition rules. So we are going to apply here. Instead of cos, I'm just going to put sine. So the sine phi is opposite side by hypotenuse, so I can easily find what is Fn. So Fn is Fq sin pi. So Fn is Fq sin pi. Okay, fine. So now so I'm just also replacing this Fq with this term. Okay, that is piston effort. So I'm just going to convert all those final equation in terms of Fp. Okay, so initially if I know what is the value of Fp, then I can just find out all those values easily. Okay, by substituting Fp value in the equation. Okay, and here sin pi divided by cos pi, just replacing it with tan pi. Okay, so this is the relations that we need to remember while solving the problem to find the thrust on the side of cylinder walls, that is Fn value, exactly the reaction force. Okay, so next we are going to calculate what is the crank effort. Okay, so this element of force which is applied on the crank pin as a result of force on the piston. Okay, it is exactly perpendicular to the crank. So what is the direction of this crank effort? It is well uh, understood that it is exactly perpendicular to the direction of the crank length. Okay, and because of this, the turning moment on the crankshaft is created. Okay, so it is a very important force as far as engine force analysis is concerned. So it is perpendicular to the, so where it is perpendicular to the direction of the crank. So it is the direction of the crank, so it is exactly perpendicular to the direction of the crank, and it gives the turning moment on the crankshaft. How? So force multiplied by this distance. What is this distance? It is R. So that is going to be the turning moment which is acting on the crankshaft. Okay. So this force is very important as far as engine force analysis is concerned. It's a crank effort which is perpendicular to the crank. So here it is the crank. Okay. So it is just positioned exactly perpendicular to the crank length. Okay. And the turning moment which is created by this force is the driving torque as far as engine is concerned. Okay, so what is its magnitude? Force, that is Ft, multiplied by this perpendicular distance, that is radius. Okay, that is going to be the turning moment, Ft multiplied by R. So now before finding the turning moment, that is what our ultimate aim. So what is the turning moment on this crankshaft? So we must know what is crank effort. Okay, that is Ft. Okay, for that, so I'll just explain this diagram. Here what I have done is I just extended this line. What is that? Fq, because Fq we have already found from the previous calculation. Okay, and then I've just drawn a line which is exactly perpendicular to this FT, perpendicular to this FT. So these two lines are joined here, and just I found this point. Okay, so first what I have done is FT is the exactly perpendicular to the crank. So this point I've just drawn this line, that is FT, it is okay. And then I have just extended this line FQ, because I know what is its magnitude from our previous relations. Okay, so I can just extend that to this level. Okay, then just drawn a perpendicular line from this line. Okay, so perpendicular line, so I just got a triangle here. Okay, and also here another force you can just find here is FP. Okay, so this force is acting on this bearing. Okay, so how to find out this force is this force just acting along the direction of the crank, along the direction of the crank. So I will just extended line from this point, okay, along the direction of the crank. Okay, that is FP, so which is the force which is acting on this crankshaft bearing. Okay, so the forces are FT, FP, and FQ, and FQ. There are three forces. One is FT, which is perpendicular to crank, and one is FP, which is along the direction of the crank, and another force is the force which is acting along the direction of the connecting rod length, that is FQ. So there are three forces at this point C. So I'm just going to construct the free body diagram for this point C. Okay. Before moving on to drawing that free body diagram for the point C, let us find out these angles, because I need to know exactly what is this angle is. Okay, so for that I'm just coming to this point. So initially I want to find out this angle. Okay, this angle, how to find out this angle is the total angle in a triangle is 180 degree, that we all know. Okay, so the total angle is 180 degree as far as any triangle is concerned. Okay, and this angle is theta and this angle is phi. Okay, so this angle must be 180 degree minus theta plus phi. And then I'm just moving to this side. Okay, okay, so I'm just moving to this side. I want to know this angle, what is this angle is. Okay, so in order to find out this angle, I've just here what I have done is I just extended the line. So the total angle in a straight line is 180 degree. The total angle in a straight line is 180 degree. Okay, so already I have some angle which is known, that is 180 minus theta plus 5. Fine, theta plus 5. Okay, so this angle, that is this angle, can be found by doing this calculation. That is the total angle in a straight line is going to be 180 degree minus the remaining angle, that is 180 degree minus theta plus 5. And here we can just, if you bring this minus inside this element, so what would happen is minus 180 here, this minus minus theta plus phi. Okay, this is it. Okay, and finally I will get an angle of theta plus phi. So this is the angle theta plus phi. Okay, and what is my final calculation is, here I need to know this angle. So if I know this angle, then I can go for applying trigonometry concept. So that is what my ultimate aim. That is why I just moved from this point to this point. I just found this angle, and then I found this angle, and then I need to find this angle. Okay, so the total angle is 90 degree here, because the crank effort is perpendicular to the crank, so the total angle is 90. So this angle is, it's very simple, 90 minus this angle theta plus phi, 90 minus theta plus phi. Okay, fine. So now I'm just going to construct a free body diagram for this element. Okay, for a point C. So this is the free body diagram. Okay, so this angle is 90 minus theta plus phi. Okay, 90 minus theta plus phi, and this is the force, that is Ft, and this is the force Fq, and this is the force Fp. Okay, so we all know that how to construct a force polygon. Okay, Okay, suppose if you just want to construct this force polygon, means FQ, it is exactly in the same direction of this force, okay, and its magnitude, and then FP, which is exactly in the same direction, okay, and in magnitude also, and this force, that is Ft, which is also in this direction. So this is how you need to construct the force polygon. Fine. And now I'm just going to find out these values. Okay, so what are all those values? That is, I need to know what is Fp and what is Ft. Okay, Ft is the crank effort, and Fp is the force which is acting on the bearing. Okay, fine. So I'm applying this cos 90 minus theta plus phi, which is equal to this one, that is Ft divided by Fq. Okay, yeah. And I'm just expanding that term. Okay, that is, I'm just bringing this Fq on this side, that is Ft is equal to Fq. So instead of cos 90 minus theta plus phi, I'm just replacing it with this sin theta plus phi, because we know that uh, cos 90 minus theta is equal to sin theta. Okay, so by using that condition, I'm just going to replace this cos 90 minus theta plus phi with sin theta plus phi. So Ft is, so instead of Fq, I'm just replacing it with Fp by cos phi sin theta plus phi. Okay, so this is the equation that we need to remember as far as finding crank effort is concerned. Okay, so as I told you, in every relation we have to get it in terms of FP, that is piston effort, so that we can easily solve the problem. Okay, once you know the FP value, we can just move on to finding all those other values. Okay, starting from force on the cylinder walls, force on the that connecting rod and crank effort, everything that we can find out by using this FP value. So that is why we want to convert that everything in terms of FP. Okay, so this is a relation that we need to remember if you want to find out the crank effort. Okay, and next I'm just going to find out the this value FP, that is thrust on the crankshaft bearing. So how to find out that value? So instead of cos, I'm just putting sine here, sine 90 minus theta plus phi, which is equal to Fp by Fq, and Fp is equal to Fq cos theta plus phi. It is sine 90 minus theta. I'm just converting that into cos theta plus phi, and finally I just got that relation, that is Fp is equal to Fp cos phi cos theta plus phi. Okay, so this is the equation that we need to remember to find out the value of thrust on the crankshaft bearing. Okay, so this is the equation that we need to remember. Okay, fine. So that is Fp divided by cos phi cos theta plus phi. Okay, the next thing is very simple, because we know what is Ft is. Okay, we know what is Ft is. So Ft is this one. So the crank effort is known. So the turning moment is going to be Ft times the radius. Ft times the radius. Okay, that is what the thing we are going to find out in this turning moment. Okay, so the turning moment is Ft multiplied by R. Okay, so instead of Ft, I just substituted the term which we have found from the previous calculations. Okay, so this is the relation that we have to remember if you want to find out the turning moment on the crankshaft. It is the summary of the engine force analysis. It gives all the formulas that are required to carry out the engine force analysis. Thank you.